In question 10a, the coordinates of 2 points A and B are -7, 3, and 5, 11 respectively. We have to show that the equation of the perpendicular bisector of AB is 3x plus 2y equals to 11. So in the first step, to find the equation of the perpendicular bisector of AB, we'll first find the gradient of AB. So that will be y2 minus y1 divided by x2 minus x1. That will be equals to 11 minus 3, 8 upon 12. Simplifying this, the gradient will be equals to 2 upon 3. So as the gradient of AB is 2 upon 3, the gradient of the perpendicular bisector will be the negative reciprocal. So we can write that the gradient of the perpendicular bisector will be equals to negative 3 upon 2. Now the perpendicular bisector will pass through the midpoint of AB. So in the next step, we'll find the midpoint of AB. The formula for the midpoint is x1 plus x2 upon 2. So that is -7 plus 5 upon 2, comma 3 plus 11 upon 2. Simplifying this, we'll get -2 upon 2, which is -1, and 11 plus 3 upon 2, which is +7. Once we have the midpoint and the gradient of the perpendicular bisector, the equation will be y minus y1, which is 7, and it will be equals to the gradient m, which is -3 upon 2 into x minus x1. So as x1 is -1, so this will become minus minus, it will become a +1. Cross multiplying, we'll get 2y minus 14 is equals to -3x minus 3. 3x will go on the left hand side, so this will become 2y plus 3x, and this will be -3 plus 14. Simplifying this, we'll get 2y plus 3x is equals to 11, which was the equation that we had to prove. In part B, it says a circle passes through A and B and its center lies on the line 12x minus 5y equals to 70. We have to find the equation of the circle. Now to understand this question, first, let's make a circle over here. And we know that A and B lie on the circle. So A and B lie on the circle somewhere. And the center of the circle lies on the line, which is 12x minus 5y equals to 70. So let's say this is the center and it lies and it has an equation. The line has an equation. So it's not necessarily a diameter, but the center lies on the line. So we can just say that this line has an equation of 12x minus 5y equals to 70. Now in the previous part, we found that the perpendicular bisector of AB had the equation which was 2y plus 3x equals to 11. And if we have 2 points on the circumference, and if we make a perpendicular bisector from this point till the center, it basically makes a right angle up here. So from the center, it makes a right angle. And as we already have the equation of this perpendicular line, which was 2y plus 3x equals to 11. So this equation was 2y plus 3x equals to 11. If we solve these two equations simultaneously, we'll be able to find the coordinates of the center. So one of the equations is 2y plus 3x equals to 11. The other equation is 12x. So we can write it as minus 5y plus 12x is equals to 70. To solve it simultaneously, we can first make the x values equal. So we can just simply multiply this equation by -4. We can also make the y values equal. So it depends. In this case, I'm just making the x values equal, and we can multiply this by 1. So the first equation will become -8y minus 12x is equals to -44. And this will be -5y plus 12x is equals to 70. So 12x will cancel. -5 minus 4y is a -13y, -44 plus 70. So that will be equals to, I think that's a +26. Y will be 26 divided by -13, which is equals to -2. Once we have the value of y, we can substitute this into either of the equations to get the value of x. So using the first equation, we will get 2 into -2 plus 3x equals to 11. So 3x will be equals to 11 plus 4, as this will be a -4 up here. So this will be 3x is equals to 15 and x will be equals to 5. So we now know that the center has the coordinates 5, -2. Now to find the equation of the circle, we also need the radius. To find the radius, we can find the distance of the center from point A or from point B. Either ways, the radius will be the same. So the coordinates of point A are -7 and 3. And the coordinates of point B are 5, 11. So we can use any of these two coordinates. Well, let's use a coordinates of B to find the distance or the radius. So the radius will be equals to, we can say, the distance of the center from B or the center from A. So finding the distance CB, C is the center and B is the B is the point on the circumference. So we can use x2 minus x1. So that will become 5 minus, so both have coordinates 5 in this case. So that will become 5 minus 5 whole squared plus, and the y coordinates will become minus 2 minus 11 whole squared. So this will be minus 2 minus 11 whole squared. 5 minus 5 is a 0. So the coordinates of CB, the distance of CB will be equals to 0 squared plus minus 13 squared, which is equals to square root of 169. So the radius will be equals to 13. Once we have the radius, we can write the final equation, which is the general form for the equation of a circle is x minus a whole squared plus y minus b whole squared, which is equals to r squared. A and b are the coordinates of the center. So we can write this as x minus 5 whole squared plus, so as b, the y coordinate for the center is minus 2. So this will become a plus 2 whole squared. And the radius is 13. So 13 squared will become a 169. So the final equation of the circle will be x minus 5 whole squared plus y plus 2 whole squared is equals to 169.